So hello students. So in the last class we have started with the module 4. So that is on embedded system design concepts, and we have already discussed few things. So we already discussed about the introduction and the characteristics of an embedded systems. So we know that now what are the important characteristics of an embedded system are like application and domain specific, reactive and real time, operation in harsh environment, distributed, small size and weight, power concerns. So these things we have already discussed in our last class. Now today we'll start with the quality attributes of an embedded systems. So basically quality attributes are non-functional requirements that need to be documented properly in any system design. So whenever you are planning to design an embedded system, this particular quality attributes has to be properly documented about your particular embedded system. If the quality attributes are more concrete and measurable, it will give a positive impact on the system development process and the end product. So basically, if you already know this particular quality attributes, you have properly documented that, then it will have an impact on your system development and the end product. So you basically previously only knowing about what you want to build, what should be the features or what should be the characteristics of that particular system. So if you know this particular things previously properly well defined, then it will have an positive impact on the development and the end product whatever you are developing. Okay, so the various quality attributes that need to be addressed in any embedded system development are basically classified into two categories. The first one is a operational quality attributes and non-operational quality attributes. So let's discuss them. So first we'll discuss about the operational quality attributes. So basically the operational quality attributes represents the relevant quality attributes related to the embedded system when it is in the operational mode, okay, or online mode. So whenever that particular embedded system is running, the important quality attributes coming under this category are like response, throughput, reliability, maintainability, security, and safety. Now let's discuss this particular attributes one by one. So we are saying whenever this particular embedded system in the operational mode or the online mode, then we are discussing about the operational quality attributes. So what is response? So basically response is a measure of quickness of the system. Okay, it gives you an idea how fast your system is tracking the input variables. So how fast it will take the input and how fast it will respond based on that input and give us the output. That is what we are saying response. Most of the embedded system demands fast response which should be real time. Okay, most of the embedded system needs this response has to be in a real time. So we have discussed so many example about this, like a anti-lock braking system or your flight control systems, right? They need a response has to be very fast. So it should take the input and quickly it should give the output, because this particular embedded systems are critical one, okay, where that response has to be in a particular time. So as an example here, like a flight control application should respond in a real time manner. Any response delay in the system will create potential damages to the safety of the flight as well as the passenger, right? We know that like flight control is a critical one embedded system where a flight has to fly in the environment, like in the air, and there it has to take care of so many such parameters, and based on that it has to take some actions, right? So this has to be very fast. So it is not necessary for all the embedded system that the response has to be like real time. Many of the embedded system it doesn't, like we have already discussed about this, so doesn't need that response has to be quick. So like here you can take an example of an electronic toy, like simple example, if you are pressing A, that particular embedded system is pronouncing that A, so it is doesn't require a very fast response. Sometimes even if it's taking more time to respond, it's okay for that, right? So that is basically what is response. So the embedded system, that response is nothing but like a quickness of the system. Then next one is a throughput. The throughput deals with the efficiency of a system. Okay, it can be defined as a rate of production or process of a defined process over a stated period of time. Like in this much of time, how much is the output you are getting, how much production you are doing in this much time period, right? Simply that we can say that as a throughput. Like simple example, you can take a printer, right? So how much prints that printer is giving you in 1 hour, so that I can say like a throughput, right? So obviously you will go for the one which is giving you more prints in lesser time, right? In 1 hour someone is giving you this many prints, so that is the throughput of the particular embedded system we are saying. Okay, so definitely when you want to buy a particular system, you will check about the throughput of that, so which is giving you better throughput, that you will select, right? The rates can be expressed in terms of the units of product, batches produced, or any other meaningful measurements. How you can measure the throughput, it depends on like particular embedded system which you are talking about. Like in case of a card reader, like the one used in the buses or like one used in railway stations, okay, throughput means how much transaction the reader can perform in a minute or hour or in a day. Okay, so throughput is generally measured in terms of a benchmark. A benchmark is a reference point by which something can be measured, right? So it is not like that every time if you decided the throughput is 100, so every time it is giving you 100, it is not like that. Like it is a benchmark, we have decided 100, sometimes it may give you 99, 98 as output, like a printer if you are saying, right? It may give 99 or it may give 102, like that something. So based on that particular benchmark we are deciding about the throughput. Benchmark can be set of performance criteria that a product is expected to meet a standard product that can be used for comparing other products of the same product line, right? So that's what I said, you have different printers from different vendors, so this may give different throughput, this might be given different throughput, so you are gonna check with all the quality attributes and then you are deciding which one you want to buy, right? The next quality attribute is a reliability. So reliability is a measure of how much percentage you rely upon a proper functioning of a system. Okay, so how much we can rely on that particular system, that every time it will work properly. Like simple example of a printer if you are taking, right? So sometimes that may there may be a failure during the printing or something, right? So how much we can rely on that particular system. So sometimes we buy something and it will not work properly, so that is what we can say, that the reliability is very low. Always it is having some problems with that particular system, again you need to repair that, again it is having some problem. So this is the quality attribute, that is the reliability, which is going to decide how much we can rely on over that particular system. Okay, so here mean time between the failure and mean time to repair, these two terms are going to define the system reliability. Okay, mean time between the failure give the frequency of failures. So first it was a failure in this month, again in the next month also there was a failure, like that. Okay, so that is going to give us the frequency of failures, and mean time to repair will specify how long, how much time it will take to repair and how much time our system will be out of service. Okay, for critical applications or the critical systems, this particular repair time has to be very less and our system should again quickly be in action, that is required, right? So next one is maintainability. So maintainability deals with the support and the maintenance to the end user or a client in case of technical issues and product failures or on the basis of a routine system checkup. Okay, maintainability. Reliability and maintainability are considered as two complementary disciplines. A more reliable system means a system with less corrective maintainability requirements and vice versa, right? Because if we are saying that the system is more reliable, so obviously it is not having any failures and it is not giving any problems, so there is no need of a maintenance for that particular system. Yes or no? Like simply you can take an example of like your bikes and all. So you go for the servicing because the maintenance required for that particular bikes after some particular time. Yes or no? So the same way, we can say that like an embedded system also requires some maintenance for that. So if the reliability is good, the problems in that particular systems are less, we don't need much maintenance for that. Like maintainability is not required for that if it is good, more reliable. Okay. Now this maintainability can be classified into two types: scheduled or a periodic maintenance. Like uh, it can be called as like preventive maintenance. Like example, we can give an inkjet printers uses ink cartridges, right? That printers need that cartridges inside it. So which are consumable components, and as per the printers manufacturer, the end use should replace that particular cartridges after n number of prints, right? So because that cartridges are like consumable, so ink is consumable, so after that many of prints you need to change that particular cartridges. So we are saying it is preventive maintenance. So once it is over, you know that this many prints are done, then you are replacing. That is the maintenance required, which we are saying it is a scheduled or periodic one. Okay. And the maintenance to unexpected failures, so corrective maintenance. So sometimes if it is finding some failures, like paper feeding part of that particular printer has some problems, so that is nothing but we are saying as a unexpected failure happened and it required some corrective measures for that. Hence it is obvious that maintainability is simply an indication of the availability of the product for the use. Okay, so whether the product is available for the use or not. In any embedded system design, the ideal value of availability is defined as the availability is equal to mean time between the failures upon mean time between the failures plus mean time to repair. That will give us the availability of the particular embedded system. Okay, so this is about. So the next quality attribute is operational quality attribute is security. So confidentiality, integrity and availability are the three important measures of information security. Confidentiality deals with the protection of data and application from unauthorized disclosure. Integrity deals with the protection of data and application from unauthorized modification. Availability deals with the protection of data and application from unauthorized users. Okay, certain embedded system need to take care of all the security measurements. So simply example, you can take an electronic safety deposit locker, which is used, which can be used only with some pin or a password, right? So that is what we can say, that the security has to be taken care if you are dealing with some kind of embedded system where security is more important. Okay, so then the next one is safety. Safety deals with the possible damages that can happen to the operator or public and the environment due to the breakdown of an embedded system or due to the emission of radioactive or hazardous materials from the embedded product. So some kind of industrial embedded product or something, if we are having there it has to be taken care of the safety issues of the operators or even the environment. Some of the embedded systems which are mainly designed to work in like a harsh environment and all, so there has to be some safety measurement has to be followed by the operator, so that he will be safely using that particular embedded system. Okay, or you might have seen the safety instructions on many particular embedded devices in your home also, like on a refrigerator or a TV or anywhere you might have seen some stickers like showing the safety measures. So that's what this particular quality attributes, as we said initially, they are properly documented. So if they are properly documented, once by reading them, anyone who is buying that particular embedded system will know about that particular embedded system properly, and he can decide which one he can go for, how much he can rely on that particular embedded system, what all like attributes it is providing. Okay, so that's what we're saying, this has to be properly documented, or so that the user can read it and properly follow that things. Okay, so these are the safety measures has to be followed for some particular embedded system. So the breakdown of an embedded system may occur due to the hardware or failure or the firmware failure. Okay, the safety analysis is a must in product engineering to evaluate the anticipated damages and determine the best course of action to bring down the consequences of the damages to an acceptable level. Okay, so if they are working on this particular embedded system, they have to take care that the safety issues has to be properly handled so that the damages can be lower and lower. Okay, so these are about the quality attributes, operational quality attributes of an embedded system we have discussed.